In problem number 9, we're asked to find the moment of inertia about the centroidal x and y axis. This video will show the solution of the moment of inertia about the y centroidal axis. The first thing we want to do is establish where the y centroidal axis is. Again, that's fairly simple in this particular problem. Since it's a symmetrical shape, the y-axis lies directly in the middle of the shape. We then want to break it into standard shapes that we know how to deal with. That would be the large rectangle and then the circular hole cut from that rectangle. Going into our table, the rectangle, the moment of inertia about its centroidal y-axis is 1/12 base times height cubed. The base in this case is the 10-inch side. The height is the 8-inch side. Calculating that out, that comes out to 426.67 inches to the fourth. The area, of course, is 80 square inches. The d distance is 0. There is no distance between the centroid of that 8 by 10 rectangle and the centroidal y-axis of the whole shape. So, using the parallel axis theorem, which says I centroid plus 80 squared equals I y total, we get 426.67. The hole that's going to be cut out from this is, again, we can get the moment of inertia about its centroidal y-axis as pi radius to the fourth divided by 4. When we do that with a radius of 3.6 inches, note that that is a negative number. We always treat holes or cutout areas as negatives. The area of the circle is negative 40.7 square inches. The d distance is again 0. The centroidal y-axis of that circle is in the exact same place that the centroidal y-axis of the whole shape is. Therefore, there's no distance in between them. So AD squared 0. So IYC plus AD squared is IY total for the whole. We then sum up the IY total column, and that's going to give us 294.75 inches to the fourth, or you can round to 294.8 inches to the fourth.